Hey everyone, I'm here with Paul Underwood. He's a principal AWS Solutions Architect and he specializes in healthcare and life sciences. Paul is the author of the AWS Biotech Blueprint Quick Start, which is a tool used to help get biotech and life sciences companies up and running on AWS in about 45 minutes. The Quick Start leverages CloudFormation templates to stand up a compliant landing zone in the cloud. So for today's session, Paul is going to walk through the Biotech Blueprint Quick Start deployment. He's going to show how to deploy the actual Quick Start and explain what AWS resources are being installed throughout the session. So with that, I'll hand it over to Paul to get started.
Thanks, Alexis. Hello, everyone. What we're going to do first is we're going to go through a quick number of kind of architecture diagrams and list of kind of major features that come along with the Biotech Blueprint, so you understand kind of what we're going to be building, and then we're actually going to go about the process of actually deploying the environment. So the genesis of the Biotech Blueprint was working with just a number of biotechs over the years, seeing the same story over and over again, where there was a need for a secure kind of research environment in the cloud, but not a lot of consistency among the startups on how that was getting done. And oftentimes it involved third-party consultants, contractors coming in and really doing a bunch of work that was always different and kind of very inconsistent. And so in partnership with our VC community and others, startups that we've been working with, we came up with the Biotech Blueprint as a means of kind of repeatable, turnkey kind of research environment in the cloud. There's sort of two main components of the Biotech Blueprint. The first is the core template, which is what we're going to primarily focus on today. The core template is responsible for setting up the sort of core foundational research environment in the cloud. This includes sort of the foundational controls for security, reliability, and management. And I'll talk about that as we go along. The other half of the blueprint is that we have partnered with a number of sort of leading informatics vendors out there and packaged up a number of their tools, both sort of commercial as well as open source tools, inside of what we're calling the Biotech Blueprint Informatics Catalog. And I'll show you at the end of this what it looks like, but the idea is if you need things like ChemAxon or you're looking to run things like Nextflow pipelines, we've bundled up those deployments into Service Catalog that you can deploy into your blueprint after the deployment's complete if you need them. That's totally optional, but it can help you get to running things like omics pipelines or get chemistry, compound databases in place before and really just a matter of minutes. So the deployment model for this is that we'll deploy the core template. You really deploy that one time, kind of to start to build that home that you're going to kind of start moving your furniture into. And then the informatics vendors, like I said, it's totally optional if you want to use them, but if you do, they're made available for you through Service Catalog, and I'll show a demo of that when we get to it. But it's from there where you can, whenever you're ready, choose to deploy some of those components that are included in the catalog today. So what comes in that core infrastructure? Really a foundational VPC. This is a classic AWS VPC that follows best practices in that it says a number of sort of core components right at the start for achieving high availability. So first you'll see that there are sort of three different classes of subnets. You'll see two DMZ subnets. These are effectively your public subnets where your load balancers might live. Anything that needs to be internet addressable may live in there. Oftentimes in research environments, there's really not a good reason for most of those things to be public. And so we have the application subnets here, which are private. These are not internet addressable and only routable through VPN, which we'll talk a little bit more about in a minute. And then finally, we have this sort of database class of subnets, which are really tight, restricted subnets where you really want to put your most sensitive things that should never be routable to the internet and have restricted routing into things like the DMZ subnet. The database subnet is really generally for databases. The vast majority of compute instances that most biotechs launch in this are actually in these app subnets. So why are there two of the of each class of these subnets? Well, these subnets on the top are in a different availability zone from the subnets on the bottom. And so if you're not familiar with regions and availability zones within AWS, a region is a geographic area like North Virginia. An availability zone is a distinct physical data center within that region. And so by having and distributing your subnets across two different sets of availability zones, it gives you the baseline or the fundamental infrastructure in place to be able to flex into a different physical data center in the event of something going wrong in the other one. So that could be, and some of our tools, like for example, our RDS relational database multi-AZ feature supports that kind of automatic failover for you. But that's why there's two. And we also supply a VPN. This is a critical means of connecting to your resources in the cloud. This would be something that you install on your local machines. You connect to it, and then from there you get a private IP address inside your research VPC, and you can SSH or reach into your databases or your application subnet once you're connected to the VPN. And it's just a fundamental thing that every really company in the cloud should be using to connect to the resources that are running inside. So there's a lot more going on besides the research VPC. The fundamental sort of control set that the AWS Biotech Blueprint follows is based on our NIST compliance package. Which is similarly rooted in our HIPAA as well as our high trust packages all share the same, and the Biotech Blueprint all share the same common set of controls. And one of those includes having a separate management VPC you see pictured on the right here for more IT operations stuff. It's important to have a separation of responsibility between the research VPC and the management VPC. As you want your IT operations things like security appliances or Active Directory or logging appliances to live in your management environment, and your research environment you reserve for actual science and research. We set up a peering relationship between those two so that they can communicate, but we generally want to have a separate location for those different types of activities. We're going to talk some more about some of the other things that you see pictured on the side here, but it's also worth mentioning that we set up a internal DNS solution here for your users once they're connected to the VPN, as well as when within your VPCs, you'll be able to use private DNS resolution. And you'll see that during the demo. So some of the other things that were pictured there we'll dive into here include creating a set of best practice sort of user sort of employee role based groups and IAM policies associated with those groups based on job function. So for example, system administrator, IAM administrator, read-only billing administrator for your CFO. These groups are again tied directly to NIST and high trust control IDs, and you can see those documented in those respective quick starts. But these things come with policies like requiring MFA for your IAM administrator, right? As a condition on the IAM policy that's associated with it. You don't have to use these to take advantage of the blueprint, but these are definitely something to take a look at or try to take advantage of, as they really do bake a lot of best practice IAM policies and conditions into these different role types. Logging is important for your AWS account, right? Not just within your applications, but setting up logging for how your actual AWS account is being used is really something critical that every company should be doing. And so this includes setting up logging on the event as well as alarming on the event for things that really shouldn't be changing very often. So you really should never be logging in as root. You should never really be executing IAM changes, or you should be made aware of when IAM is being changed, when people are changing network ACLs, when people are turning off CloudTrail. Like these are all events that you should be made aware of and logging. And so we set up all the necessary cloud trails for those activities. as well as setting up the bucket where all that log activity goes to, and following proper lifecycle policies to move some of those logs into cold storage, again, based on NIST and high trust recommendations that all of these quick starts inherit from each other. So we've talked about the preclinical VPC. We've talked about the management VPC. Now let's talk about some of the config rules that are setting up. It's one thing to be alarmed on when things are happening on your AWS account. It's another just to be alarmed when people are doing things in your AWS account, launching stuff the wrong way, and being able to alert and alarm on those things is just as important. And so there's a number of AWS config checks that get set up as well for alerting you when instances are launched with unrestricted ports. People are launching instances with OpenSSH. It also has a check to make sure that people don't turn off CloudTrail. Things to that effect all kind of come baked into these config rules. And you'll see us turn on config here shortly. And so those are the major components of the core portion of the Biotech Blueprint. We'll walk through some of the sort of the informatics catalog once we get into the actual deployment. You can see some of the current vendors that are participating. All right, so with that, I'm going to go ahead and pop over to the deployment guide. So this is the AWS Biotech Blueprint deployment guide. You can find it on the AWS Biotech Blueprint Quick Start page. You can see some of the currently participating vendors here. Chemaxon, Dotmatics, Nextflow, for example, is an open source example. You can download the deployment guide here, but what I'm going to do today is kind of basically give you a visual run through of the deployment guide and what you'll need to do to deploy it. And so in the deployment guide, there's a prerequisite section, and so I'll kind of quickly walk you through what you'll need to do, what you'll need to have in place in your account before you get going. So the first is setting up the needing the necessary limit. Limits raised in your account. There's really only one limit that we need to raise, and that's the number of EC2 VPC elastic IP addresses. Right now, you can see that current limit is 5, and the Biotech Blueprint requires at least 6. And so if you're already using some elastic IPs in your account, you'll want to request a limit increase that gives you at least enough to launch 6 more. Go ahead and give yourself a little bit extra, as you'll need them, but we'll want to bump this up to at least 6. And you can find that limit by going to the EC2 portion of the console, going to the limits here on the far left, and then searching for EC2 VPC elastic IP address. And so you can see mine's already currently been raised, but what you would do to request a higher limit is you click this request limit increase button. You'll see it should auto-populate the request service limit increase, the limit type. What you'll need to do is just specify the region that you're doing this in. I'm doing this in Northern Virginia. I'd set the limit to that VPC elastic IP address limit, and I set that value to something like 10. Put a note in here that you're deploying the Biotech Blueprint Quick Start and need more elastic IP addresses. Hit submit, and then wait about 10 minutes, and then recheck the limits page, and you should see that number go from what it was before to what the limit increase was, like where you saw mine was at 10. So once that's done, while that's sort of cooking, like again, it should only take about 10 minutes for that request to come through. But while that's cooking, we'll go ahead and get the other pieces set up. Now, we will need a key pair for the deployment. This is really only used in the event that you're deploying in a region that doesn't support the NAT gateway, but most regions do, but it's still required. So hopefully you've already got a key pair. If you don't already have a key pair, follow along. If you already have a key pair created, that's fine. We can just reuse that. What we'll do to create a key pair here is we just hit the click create key pair button. I'm going to call this Biotech Blueprint Demo. Doesn't really matter which file format. Like I said, it's not used, but we will need it for submitting. So once the key pair is created, you'll see it's downloaded here on the left. You might save that for later. You might want to reuse it. But the next thing that we need to do is turn on AWS config. So in the search, type in config, and that will take you to the AWS config console. The first time you come to config, you'll see this sort of blue button, and we're pretty much going to go blue buttons all the way down. So just accept all the defaults all the way, and this is effectively turning AWS config on in this region for this account. So this won't take too long. And that's it. So once that's complete, so just to kind of go back over the prerequisites, we requested the Elastic IP limit increase, we created a key pair, and we turned on AWS config. After those three things are done, we're pretty much ready to actually launch the Biotech Blueprint. And so just the kind of one of the quick links to to launch it will be this quick launch the quick start button. There's a similar launch button in the deployment guide as well. And that will take you directly to the CloudFormation template. This is where it's actually going to start creating the VPC. You'll see here that the region right now is picked in Oregon. I'm going to go ahead and change that back to Virginia. So double check when you get to the screen, make sure it's deploying into the right region. Once that's complete, once you know you're in the right region, go ahead and we're going to start deploying the stack. So I like to use a kind of abbreviated name here for the stack name. The first parameter is the internal DNS that I mentioned. So this is going to be when users are connected to the VPN or any resources inside your VPC, we'll be able to reference this domain name and it will be purely internal DNS. And I'll show you an example of that before the day's out. But the idea here is that, I'll put in my example company as the domain name so that when I want to go to my personal development machine in the cloud one day, I can just go to dev.examplecompany.com and I'll have that internal IP address resolved cleanly. So just as an example there, you'd want to put your company name there. Leave off the .com, right? This is just the second level domain. You can change it from .com to .org or what have you on this is the actual top level domain parameter. On the availability zones, we'll want to choose at least 2 different availability zones. I choose US East 1A and US East 1B. These are the CIDR ranges, the class CIDR ranges that we'll be using for the preclinical or the research VPC and the management VPC. If you don't really know what these are or don't care, you can just safely leave the defaults. The notification email address here would be, this is where those alerts are going to go. This is where the alerts will go that that the AWS config and some of those other things that I talked about before will get sent to. We want to go ahead and enable config so we get the benefit of those alarms. We'll select our key pair that we created earlier. And again, if you already had a key pair in this account, you would see that key pair listed in this dropdown. So you just select that. We want to supply a managed VPN. So we want users to connect over a VPN to reach our private resources. So we'll leave that as the yes. This VPN CIDR range is essentially the client range that when people are connected to the VPN, this is the IP range that they'll be given. And then here's the inbound CIDR range. So this is what CIDR range you want to allow people to connect from. So if you only want to allow people to connect from your corporate office, you would supply your corporate office IP address here. If you want to allow people to log in from home or hotels or coffee shops or what have you, you pretty much need to leave this as 0.0.0.0/0 to allow basically anybody who's on the internet to attempt to connect to the VPN. If they don't have the appropriate certificates, they won't be able to, but this gives people the flexibility of connecting from wherever. Here we're going to create the informatics catalog. We want to include that so I can demo that. And once that's all set, we hit next. You can pretty much just continue along accepting the defaults here. Make sure you check these two boxes and hit create stack. So quick note on what's happening here. What we just used is CloudFormation, and CloudFormation is a tool that lets you specify infrastructure as code. And here you can kind of see the actual source code to the template, to the Biotech Blueprint. But what we essentially did was deploy this template with the parameters that we just specified, and that's going to start provisioning resources under the hood. And so you'll remember some of those IAM, best practices I talked about earlier in terms of different roles for different sort of job functions. You'll see those getting created right now here. And if it's definitely worth it to go take a look at some of these roles and some of the instance profiles, sort of the roles and the groups and the policies, as there's a lot of really good practice in there. And I mentioned the sort of NIST and high trust control IDs that the controls that the Biotech Blueprint is taking advantage of as well. There are, if you do have high trust or HIPAA concerns or requirements, you can go to those respective quick start pages, download the security controls matrix, and you'll see for very specific citation or control IDs, the individual templates that are being deployed and the individual resources that are being deployed that address those particular points. So it's a very handy way to kind of get going very quickly. It's by no means gets you all the way, but it gets you quite far. Here's the logging template that's getting created right now. This is creating the bucket as well as the kind of lifecycle policies to properly store these logging details into cold storage over time. That's all happening here, as well as some of the alarms that get associated with that. Just while we're waiting on the stacks to create, I'm going to go ahead and show you guys what for example, the high trust quick starts deployment control matrix is. You'll see here there's these security controls reference buttons right here. And this will download an Excel file, which I'll pull up right here. And you'll see the specific high trust CSF control IDs, along with the templates and sort of AWS commentary and the implementation details, as well as like which resource types and AWS templates that are being launched here are addressing. And so, like I said, by no means a complete story, but certainly better than starting from scratch. So we'll pop back over to CloudFormation. And just to give you a sense of what's happening here, the Biotech Blueprint core template has a bunch of nested templates that sort of deploy the components piece by piece. And as soon as the next one pair that we'll see are the preclinical VPC, which is also known as the research VPC, and the management VPC. And there they are. So we named this preclinical VPC. Like I said, another name for this, you could call it a research VPC, and we will rename it so here in a moment. But as this kicks off, you can kind of see all of it that's creating. For the most part, the VPC is not the management VPC you may not use at the outset, right? If you're just interested in doing, research, give me a safe, secure home to go do research in the cloud. Give me a VPN to get me in there. that's really what the preclinical VPC and the VPN solution is for. Until you have the need for more IT operations oriented resources, like I said, Active Directory, things like that, you probably won't actually take advantage, or you won't use the management VPC until you have a need for that separation of concerns. So for now, we're going to primarily just focus on the research VPC as we go. So as this VPC is getting created, let's go take a look at it. So in my VPC list, I'll see our two VPCs that have now been created. There's that management and the preclinical. What I'm going to do is I'm actually going to rename this the research VPC. Just hit that little pencil button and hit the checkbox, and that'll rename it. We'll call this one management VPC. Management. And so we can leave it like that. That won't hurt anything. But what I want to do is look at the subnets, because this is, so we'll filter on research. And you can see our 3 classes of subnets. We've got our 2 app subnets, our 2 database subnets, and our 2 DMZ subnets. So hopefully this is connecting with the picture for you. The app subnets, let's take a look at those, because like I said, these are where the majority of your, if you want to launch a resource that shouldn't be internet facing, that's primarily just for researchers, like it's the app subnets that you want to be targeting for your deployments. And you'll see here that the availability zone associated with this one is US East 1A, whereas the second one is US East 1B. And that's important for that high availability. Running in 2 different availability zones gives you that option. There's a lot of other good reasons to have multiple availability zones in your architecture, including better usage, better opportunity to use the AWS spot market. But for right now, generally just 2 subnets at the outset is often more than enough to begin. So while that's creating, let's go ahead and take a look at the, for kicks, we'll go ahead and take a look at the management VPC. It's a little bit simpler. I'm not a great speller. So the management VP is simpler. It has two private subnets, 2 DMZ subnets. Again, you probably won't be using the management subnet at all. Just focus on the research. So while let's check back on our CloudFormation stack, see where that is. All right, so our VPC stacks are complete, and so it's going to start launching the networking and service and informatics catalog and VPN stacks next. So while we're waiting on the VPN to get ready, I'm going to go ahead and launch an EC2 instance here. I'm going to launch this like you would, imagine I'm a researcher now who wants to launch a host in one of these private subnets that I can reach into. And so what I'll do here is I'm just going to pick, like I'm running an Amazon Linux 2 machine. I'm saying I'm launching a T2 small. Then we're going to choose our VPC, and this is where the kind of the rubber hits the road. I want to launch this into the research VPC because it's a box for me to use. It's not a database, it's not internet addressable, so it's sort of an application research environment or server. So I'm going to choose the application subnet to deploy it into. And as long as I'm doing that, as long as I'm deploying my stuff into there, I know that the outside world, unless they're coming in via the VPN, won't be able to reach my resources. So I'll do we'll do next add storage, next add tags. It's just a test host, so we don't need additional space. And then we'll confirm the security group. And you may notice that this says this is open to the outside world, and we'll fix this in a minute. There's a security group that gets launched by the VPN stack in CloudFormation that you'll want to use as the security group source for allowing SSH. But for right now, we'll just leave it so we can have this machine launching while we're waiting for it to complete. So we will We're going to wait for this thing to boot up inside of our, private application subnet inside the research VPC. So next we'll go back to CloudFormation, see how that's going. And our networking environment's getting deployed now. This is primarily the private DNS settings that we mentioned before, as well as the peering connection between the two VPCs, the management and research VPC. This one generally doesn't take too long. So what we'll do here is, while we're waiting on this, let's say let's go back to that box that we launched, and we want this machine to be sort of my personal development machine that I want to connect to. And so, I know it's private. I can grab its private IP address here, and I'm going to kind of demonstrate the internal DNS capability here. If we go to Route 53, which is the service that our primary DNS service, you'll see that we have one hosted zone created based on that parameter we supplied before. And in here, I can create record sets. So let's say I want to create a record set for, Paul Dev machine, pauldev.examplecompany.com. I can put in the private IP address of that host that I launched. And then now I can refer to pauldev.examplecompany.com when I'm connected to the VPN or when I'm inside the VPC, and that'll resolve to that private IP address. So that way I don't have to memorize IP addresses all the time. I can use private DNS. So we'll connect to this though as soon as the VPN is up and running. So we'll pop back over to CloudFormation, see what progress we're making. All right, so our service catalog is getting created, and the client VPN endpoint is underway. So while we're waiting on the client VPN, I'm going to go ahead and show you guys the service catalog feature. Service catalog is our service that lets you sort of create portfolios of products that you can sort of make available to your users in your account based on their in prepackaged ways. And so we're taking advantage of that for the Biotech Blueprint. The idea here is that you first actually need to grant permissions to individual users to take advantage of this. And so I'm going to actually just kind of give access to myself for the moment. If you had other IAM users, individual IAM users that if you had other individual IAM users, you could add them directly, or you can do rules or groups. What happens is once you've added them and given them permission to the Biotech Blueprint informatics portfolio, you'll see the ability to provision products right inside the service catalog. So let's say I wanted to deploy a Nextflow pipeline to begin playing with things. I could click here to launch product. Example, Nextflow pipeline. And this is going to deploy our reference architecture for Nextflow into this account. And there's some nice benefits that happen by taking advantage of the Biotech Blueprint. Annoying details like what's my VPC ID and what's the private subnet ID and things like that. We're actually able to pre-populate those things for you through the parameter store passwords. So you don't actually have to require your researchers to know details like subnet ID and security group ID, et cetera, to take advantage of that. And so if I go back to the product list, you can see we've got Benchling and Chemaxon and Dotmatics and Partitioned, Mosaic, as well as Nextflow available right now in the catalog. And these were all made available after we deployed that core. So let's go back to CloudFormation and we'll see how things are progressing. And we have our client VPN endpoint is now complete. So what we're going to do here is we're going to go to the resources tab. So once it's done, we'll click on our client VPN endpoint stack here. We'll go to the resources tab. And then here at the bottom, you'll see the VPN config bucket. And this is where we have downloaded all of the, this is where we have uploaded the necessary certificate, key, and OpenVPN config file that you'll need to actually connect to your environment. So you'll have to click download, and then you have to, this is a little annoying, but you have to uncheck it and then check the next one and hit download, uncheck it, click that one, and then hit download. Once those files are downloaded, you'll want to load them up into your preferred OpenVPN client. If you're using Windows, I prefer to use the Windows OpenVPN client. If you're on Mac, I prefer to use the TunnelBlick client, although there is now a native OpenVPN client for Mac. I think we even have our own, AWS has its own VPN client, OpenVPN client. It's really up to you what you want to use, but it really doesn't matter which end client you use. So if you bear with me here, I'm going to be setting up my environment to include that VPN file, and I'll show you guys here as I go. So the way that OpenVPN works on Windows is that you can kind of create a folder. We're just going to test, and you'll just drag those 3 files in that you downloaded into that folder. And sorry, I've downloaded these files a few times, so it adds that prefix. I just got to clear that out. You won't have to do this if it's the first time. And I'm just going to rename this one Biotech Blueprint Test Research. All right, guys, sorry for that quick jump cut. I had to, small technical glitch. What I've done is once I've renamed the OpenVPN file there, I'm going to be able to see it come up in my OpenVPN side here, where I can connect. What's happening? There we go. We are connected. And so you'll get a warning here that you're connected. Now, to kind of prove that we're connected to this resource, what we're going to do is we're going to try to SSH into that private box that we got into earlier. If we go back to our instances, and we have our little test instance here, we're going to connect over that private IP address. And so the one thing that I'll need here is the PIM file from the key pair that we created earlier. And if you'll bear with me here. So what we're going to do is I need to drop, bear with me. I'm just getting my key pair in the right place. To get into our box, let me make this a little bigger. We're just going to do our SSH -I to our key pair that we created earlier. And then this default username is EC2 user, and then we'll put in our private IP address, which is 10.82.102.79. And again, we're just getting that from the private IP address behind it. And with that, sorry, we got to change the permissions on the key pair. I always forget to do that. And we're on to our EC2 host. So, and you can see this was done using the private IP address, and there's no public IP address associated with this host. Now, I promised you that we had the private DNS as well. So if I didn't want to remember that, that private the IP address, remember we set up the internal DNS earlier for, I think it was Paul Dev. I should probably double check that. Let's see what we set it up for. pauldev.examplecompany.com. So you can see I can just use pauldev.examplecompany.com. And then similarly, I can get into that host as well using the private IP. Now, you may remember the sharp-eyed one of those of you might have noticed that when we created that host that we gave it security group associated with that host, basically permissions from the World Wide Web to log in from the internet. Now, because this is a private host and it isn't addressable to the internet, this isn't really much of a concern, right? Although this still isn't a best practice. Let's say we only want to allow people who are connected to the VPN to be able to access this host over port 22. So what we're going to do is we'll edit the security group, and what we'll do is we'll say for the inbound rules to that host, instead of allowing access from the internet, we only want to allow access from this informatics access security group. And this is associated with the client VPN. And so any VPN users that that anybody who's connected to the VPN will have access to that security group. So if I hit save rules here, we're now our SSH port is still open, but it's not brought out to the internet. It's very tightly controlled to just those who have been, just to those who are connected to the internet. So to see that still work, we'll still be able to get into our host, even though we just applied that much more restrictive security group on the lockdown. So with that, everybody, that is essentially how to launch the Biotech Blueprint, how to launch a private resource into that environment, and then connect to it over internal private DNS over that VPN. Really, the sky's the limit for you from here. You can move to the AWS Informatics Catalog to take advantage of deploying some pre-built infrastructure stacks into your environment, take advantage of things, something like Nextflow. But really, you now have a sort of secure home to go start moving your furniture into. So feel free to reach out to your AWS account manager to connect with the solution architect if anything that you've heard today is confusing or you have any problems. Don't hesitate to reach out. We're here to help. Thank you very much. Again, I'm Paul Underwood, and I appreciate y'all's time today. Thanks.